about semantics and one of its applications on a foodie project with a special focus on APIs and ontology. So my name is Bente Lilja. I'm going to be your host today. But before we really start on the webinar, we will like to talk a little bit about the weather. This is a trademark of the Inspire Hackathon webinars, and it leaves room for the latecomers. Board here.
Okay.
No clicking. Okay, so before we start, I would like to do a weather report. We love to talk about the weather in many countries, and I will start from with you from England. I know that England, John. We will learn more about John later, but first we will get the weather report. John, what's the weather like today?
It's really boring today. Actually, it's just really dull grey sky. There's no rain, it's quite cold, maybe 4 degrees. Nothing really very exciting is happening, which is probably good news if you're out on the roads. But yeah, very dull British winter weather at the moment, I'm afraid.
Typical working inside weather.
Yep.
Yeah. And Karel, in the Czech Republic, how is the weather today?
Seems that winter finally started, yes. From yesterday we have snowing, a lot of snow is coming in our country, so all is now white. We will see if it will stay or disappear in few days.
Ah, sounds lovely. So here in Norway, I'm talking to you from Norway. We have a beautiful winter day today. I wish I could share the beautiful sky. The clouds are so gorgeous. It's painful to be in here, but I prefer to be with you. So we have had a nice sunny day, cold weather, a typical Norwegian winter. So with that weather report, I think we can start. I see we are several in the room already. Welcome so much. We are so happy that you are interested in the topics of semantics and technology, modern new generation technology in general, and the Inspire Hackathon. And you will learn more about all of this. But first, I would like to introduce you to the speakers. We do a little bit of a tour de table, and we start with John Blower. John, can you introduce yourself?
Yeah, hi there, everybody. My name is John Blower. I'm from the Institute for Environmental Analytics at the University of Reading. And until a couple of years ago, I was the coordinator of a fairly large FP7 project called Melodies, which is all about using semantics and linked data in environmental applications. So we may say a little bit more about that later.
Excellent. Thank you. I'm very excited to hear about that. And Karel, can you introduce yourself as well?
Okay. So my name is Karel Charvat. It is difficult to say from which organization I am because I'm working for Let's Project Wireless Info. I am one from founder of Plan for All. I am active in OGC Club of OSIAC in many organizations. I will speak about that in previously in foodie and data file and what we would like to do and how we would like to move with the next generation of iPhone.
Exciting. And I will introduce myself with more than my name. My name is Bente Lilja. I'm an earth science enthusiast and expert, and I work with Earth observations and management of data for many years. I'm here today in capacity of representing Plan for All, one of the key organizers of the Inspire Hackathon. I'm also representing the Horizon 2020 project called NextGeos. Otherwise, I run a small company called BLB. Today, I will be your host. And before we start, I want to draw your attention to your chat box. Some housekeeping here. We really would like to know more about you as a start, and that you can consider as a warm-up to you asking questions to us. We really would encourage you to have a dialogue with us. You have the speakers here, you are here live, so you have a good opportunity to ask questions any type of questions that you think these speakers will be able to answer. We love for you to do that. So here I will just show you and saying hello in the chat box, so you know where it is. Start to tell us where you come from, maybe a weather report, just to kick off this. Then we have two presentations today, and we start with John. And after John has presented, we will allow some questions, so that if you have some immediate questions, this will be facilitated. And then we also will have a questions section towards the end. So with that, John, I will give you the floor, and I'm excited to hear about semantics.
Okay, so I'm going to try and share my slides with you. So I'm going to click share there, and then, did that work?
It's coming, I guess. Yes, so we will.
Coming up, and now screen.
Yes, and you will see that we will disappear from. Our faces will disappear, but do not fear, we will return after John has done his presentation. And it takes a little bit of time, it sounds. Did you disappear altogether, John? I think the system might be a little bit slow. John, I think we have, yeah, I see you, John, and here you come. Yes, okay. It was just very slow.
I don't know if you can hear me.
I can hear you, John.
Okay, moving the slide a bit now.
We saw the screen. And while you're waiting, I see several. Thank you for your hellos. I'm saying hello. We have a hello from Madrid and Italy and Paris. And meanwhile, John has completely frozen.
This worked out.
John, do you hear me? We see a slide now. Can you hear me, John?
I can now, yeah.
Yeah, so I think maybe you can remember you had an SD, so a lower resolution. Maybe you should try that to see if it might be a bandwidth issue. So apologize for this, but you know.
I'm sorry about this.
Technology.
It's not turning my webcam off. I'm trying to turn my webcam off, and it's not listening to me.
No, but you need your webcam. You need the webcam.
Let me.
But can you switch to a lower resolution? And now he disappeared. He's coming back. Hello, Netherlands, Belgium. Yeah, so nice. Clouded and cold, and chilly in Belgium. In Italy, sun. I'm not surprised. So we cannot hear you, John. Is that because you haven't turned on your mic yet? So just to say that we yes, we tested this just a few minutes before, but we tested this several times, but you never know with the artificial intelligence. We were making jokes about that also before we went live. And apparently the artificial intelligence is not on our side right now, but we hope with some care we can get it back to work with us.
Now my camera is not turning on or off.
Yes, you are turning on and off. I saw you and then you disappear, Karel.
Yes, now?
Yes, I see you and I hear you, Karel.
Okay, good.
And I see John, but John left the room, so I think he will re-enter the room, probably readjusting. Meanwhile, while John is doing that, I can tell you a little bit about Plan for All. We meant this to come towards the end, but while we are figuring out the technology here, Plan for All is an NGO association registered in the Czech Republic, but we have members from all over the world, actually, mostly from Europe, more than 50 members right now. And the point is to sustain and enhance the use of results from other projects, obviously from the framework, the European Framework Program, but also national programs and other, there are other activities as well. And we work very hard to facilitate interoperability between the results and the continuation of making use of these results. So that's sort of the main motivation for Plan for All. And organizing, a very important activity that we do is to organize these Inspire hackathons. And right now you are watching a webinar that is part of a virtual hackathon called the Prague Inspire Hackathon. And I think I will continue this story after John has presented the semantics. How are you doing, John? We can see your screen now.
Okay, can you hear me?
Yes,
okay.
We can.
So if it's okay with you, Bente, I think I might avoid sharing my webcam for the moment. Maybe I'll put it back on for the questions because it seems to be causing some problems. Many apologies for that. As Bente said, we did practice this, but the best laid plans and so forth. So anyway, shall I just make a start, Bente?
I'll be delighted to hear about semantics now.
Excellent.
Go ahead.
So yeah, I'm just going to spend a few minutes introducing the field of linked data and semantic web. I don't know, some of you may on this webinar may be quite familiar with these topics already, but hopefully for those of you who are not so familiar, this may bring you up to speed, and maybe there'll be some new stuff for people who are more familiar. I've already introduced myself, so I'll skip that. So this is the way that I like to summarize the kind of the goal of the semantic web is to steal the words of Tim Berners-Lee, who obviously a World Wide Web pioneer, who said if the web made the online documents look like one huge book, the semantic web will make all the data in the world look like a huge database. And that's really what we're trying to do here. We're trying to take move from documents, so just text about things, to data that's interpretable by computers. And that means that we could do lots of really exciting things with automation and intelligence and information discovery and all that kind of stuff. You'll often see the phrases semantic web and linked data being used somewhat interchangeably, and I think that's fine. I guess the way I would look at it was that the semantic web is an application of a set of technologies that together we tend to call linked data. So I will explain a little bit about that further on, but whether you use the phrase semantic web or linked data, personally, I don't really mind too much. So just to illustrate this concept a little bit further, I'm going to just work through a very simple example from the field of Earth observation. This came from a previous project that I worked on a few years ago called CHARM. And this project was about applying linked data techniques to the field of Earth observation. And so this is a very simple representation of what goes on in the Earth observation field. That you have satellites carry instruments. Instruments produce information that's processed using algorithms to make new data sets. scientists come along and they use the data to make new discoveries, and they write publications about them, and that's what this little kind of mini web of information is intended to show. Now, if we're in the world of the standard, the World Wide Web that we all use every day, the way we interact with that information is that people will publish web pages about it, formatted using HTML. They'll be published on web servers, and they'll be linked to each other through hyperlinks. And that builds up this, what we might call the web of documents. And that obviously is an exceptionally successful way of sharing information, but it has some limitations in that it really requires a human to read that web and navigate through that web to a certain degree, because there's a limited amount to which computers can understand what is being published there. And so the idea of the semantic web is, wouldn't it be very exciting if we could make much more of that information interpretable by computers directly and use them to automatically discover all kinds of information. And so this is why we end up with this concept of the semantic web and linked data techniques, that what we can record in our data stores is a more precise representation of what's going on in the field of Earth observation. So not just a set of documents that are linked together, but we can put in our database that a certain satellite carried a certain instrument. The instrument was combined with an algorithm to produce a certain data set. The publication is linked explicitly to the data set, and the authors, the scientists who wrote them, are linked to the publication. And this builds up what we might call the web of data now, because all of those links can be found by computers and interpreted. So what can we do with this sort of thing? Well, we can answer particular questions like finding all the satellites that produce data on sea surface temperature, for example. That might be a really useful question to answer if you're a scientist looking for sea surface temperature data sets. You could find all the scientists who have published on the use of a certain well-known algorithm or a retrieval system, for example. You could find all the publications that are written about an instrument, or given a data set, you could find its whole history, in other words, its provenance, where it came from, who produced it, or what steps it went through. And importantly, we could also add our own information to that web of data, to the semantic web, which is sometimes called annotations. So people could publish their own thoughts, their own information about that data and link it correctly to the right things. And that grows the store of knowledge. So in other words, information becomes more discoverable, and we can help science by making it more reproducible. So those are just some examples of things that could be done when we have data published in this way. Other things that you might consider that are maybe more commonly used by the general public would be things like recommender engines. And you'll see this, of course, all over the place. I'm sure you've all come across these with Amazon and eBay and all that kind of stuff. And behind those technologies are technologies that are very similar to semantic web and linked data to help make these recommendations. Other stuff you may have noticed over the past few years is Google searches and searches and other web search engines are becoming more sophisticated in the information that they return. So this is an example of searching for The Martian, which is a movie, of course, and whereas a few years ago you'd have just retrieved a few web pages describing the film or describing other things that are related to that phrase, now Google knows that that's a film title. It can find out where it's showing on cinemas that are near you. It can give you the members of the cast. It can give you related movies, reviews, and all that sort of stuff, and this is all being pulled together in one place. So I just want to spend a couple of slides talking a little bit about the nuts and bolts of this, for those of you who are not familiar. So what we have to do to make these things happen is follow a set of linked data principles, and you can find more precise descriptions of these principles on the web, but these are kind of my version of them in a way. So firstly, you have to decide on the things that you care about and give them unique and persistent identifiers. So you have to call them something that is consistent and will always be used to refer to that particular thing, whether that's a movie or a satellite or a data set or whatever. You want that to be able to be looked up on the web to give you more information about the thing. So if you want to find more information about Prague, you can go to Wikipedia, of course. And in fact, there is a semantic web version of Wikipedia called DBpedia, and that will tell you all kinds of information about Prague and link it to other related stuff about Prague, like famous people who came from Prague, that sort of thing. You need to provide a description of the thing in some kind of a standard format, both human readable and machine readable. And importantly, you want to link the things that you care about to other things in the world that people care about, and say why they're linked together. And in that way, we build up this big web of information that we call the semantic web. And in particular, we refer to that web of the networks and the links and the things and the links between the things. In general, we refer to that as a graph. In the mathematical sense, it has nodes and edges and links and that sort of thing. But the overall goal is to describe things more precisely in a way that is machine readable. The building blocks, and this is where you get into the whole acronym soup of linked data and semantic web. You need uniform resource identifiers, URIs, to identify things. There's a particular structure called RDF, Resource Description Framework, and that's how we can encode these graphs of information and exchange them between databases. Really importantly, we need to agree as communities on ontologies and vocabularies, in other words, definitions of terms and concepts that we can all agree on, and the relationships between them, and then we use those to encode the information that we have. And there's a query language that works with all this kind of stuff, and it's called Sparkle. And that's what we can use to search that graph. And those searches could be performed over the web, indeed. But we should also note that RDF, Sparkle, and all these kind of things are not the only technologies that can be used to build graphs and build these kind of webs of information. But these are the open standards that are put forward by the World Wide Web Consortium and the major standards used in semantic web. But we need to recognize that other communities, particularly in the commercial space, are using different technologies here. If you want to find out a bunch of data sets that are published in this way, you can go to the linked Open Data Cloud, and the link's there. You can find all kinds of stuff on there, and it's growing all the time. It's got DBpedia, which I mentioned a minute ago, which is the machine readable version of Wikipedia. Geonames, which is a set of names for geographic things. Lots of stuff from governments, including the UK government, publishing through data.gov.uk. All kinds of things on there. If you search around, there's all kinds of fascinating data sets from French National Library. Someone's encoded a load of information about World War I as linked open data. You can even get weather forecast data in this kind of way. So lots and lots of stuff to play with in your hackathon. I felt I couldn't really talk about this subject without talking about some of the challenges that people will come across when they start to try and adopt this kind of technology. First of all, agreeing on definitions, in other words, the ontologies and vocabularies, is a big challenge. There's a lot of hard thinking has to be done across communities to agree on how we're going to represent things in this way, and that can be one of the major costs in this whole process. There's also concerns about how efficient things like RDF and Sparkle are, particularly when we get up to large data sets. And those problems are being addressed and being solved, but it's probably true to say that there's usually, if you're interested in raw speed of data processing, there's other ways of storing the data. And whereas RDF and Sparkle are extremely strong at preserving these links between data, if you just want to number crunch, then you may want alternative representations of the data as well. So we're always probably going to be living in a kind of world where we have multiple representations of the data for different purposes. It's still quite challenging to search across multiple data stores in an efficient manner, though again, that's something that people are working on. And really, this whole area does come with a fairly steep learning curve for new practitioners, and the tools are still maturing here. So it's not perhaps the easiest field to get started with, but these kinks are being smoothed out the whole time. But I think the overall challenge here is to balance these costs and all these efforts with the user benefits that you imagine that your user community will see out of this. And that's the kind of equation that you've got to balance here, because you could literally spend your whole life publishing data in ever more precise and useful formats, but you've got to be able to take your user community with you there. So this is my last slide. I just wanted to give you a few links to things that you might want to check out if you've not seen these already. So schema.org is a bunch of really simple vocabularies that will help with encoding some common concepts, and search engines will increasingly understand data that's published in those formats. You can get special RDF stores that will store optimize for geospatial data. So there's one called Strabon coming out of the University of Athens, which you can check out. If you're interested in data in JSON format, there's this JSON LD standard where which kind of interoperates between the RDF world and the JSON world. That can make linked data a lot more friendly. We've published a data format called coverage JSON, which is all about n-dimensional geospatial data, things like satellite images and weather forecasts and things like that, which again tries to bridge this gap between JSON data and RDF kind of representations. And it's also worth checking out what's going on in other communities. There are things called property graphs, which are different from RDF graphs, but are quite widely used in certain communities, particularly the commercial world. Neo4j is a good technology there. And obviously all the stuff that Facebook and Google and everybody else are doing in this space. Graph technology is quite a hot topic at the moment. So with that, I'll finish, and thank you very much for your attention.
Thank you so much, John. That was really interesting and so dense on information in a short time. So thank you so much. I have encouraged you to ask questions, and so please do that now. If you have some immediate questions for John while you have it fresh in your mind what he said, and maybe you have some questions that formed when he was speaking, please do write that in the chat box now, or think more about it and do it later. But while John is unsharing his screen, I can ask him. You might have seen in the announcement of this webinar that this work was done in among other places, but in the Horizon 2020 project called an FP7 project called the Melodies. And maybe you can say a few words about how did you apply this semantics in that project, or how was the link between Melodies and semantics?
Sure. Well, in Melodies, we were the task that we gave ourselves was to apply these kind of technologies to a number of real-world case study applications in the field of environmental data. So we worked in a few environmental fields, including agriculture, shipping, land cover mapping, all kinds of stuff. We found there are a number of challenges with applying this technology. Firstly, there's a kind of chicken and egg situation that no one really wants to be the first to put a lot of effort into publishing data in a new format when they're not sure what everybody else is doing. So Melodies was a few years ago now. It was there wasn't so much of this data being published in this format. So the benefits were a little bit harder to realize to start with, but there's a lot of benefit that you get, I think, particularly when you're describing all these links between how data sets were produced, how they were formed, how they link into publications. I think that's where a lot of the benefits come. If you're an Earth observation scientist and you just want to process satellite imagery, you probably see less immediate benefit. But I think where you get the benefits is when you're linking this to the wider world, and when you're plugging when you care about things like reproducibility and stuff like that.
I understand. And yeah, so thank you. I have a question from Emmanuel from Digital Globe. He asked if there's a link between this activity and OGC activities related to semantics and ontology.
Yeah, that's a really good question, and I think with more time, I could have gone a little bit more into those kind of questions. a lot of the activity in defining these ontologies for geospatial data is going on kind of between the OGC and the World Wide Web Consortium. They've been working increasingly closely together in order to define these kind of things. And so there's some really interesting discussions going on from people who have mainly a geospatial hat on and are learning about semantics, and people who have mainly a semantic hat on who are learning about geospatial stuff. I don't really know what to say more about that in the time that we have, other than that you can check out a lot of those working groups. There's some interesting stuff going on. Yeah, we might actually find some links to it and put that in the chat box, links to that in the chat box. I see that but we can see how much time we also have at the end, at the Q&A at the end, and we can go deeper into stuff there. I see that Emmanuel has more questions, and Emmanuel, we will address them in the Q&A. We will remember these questions and answer then, so we know more time, what more time we have, because now we will hear. John, can you unshare your screen, please? Thank you. So now we have actually, John mentioned some examples in the Melodies project, and now we have an example from this Inspire hackathon and some work that has been done earlier as well. So Karel, I give the floor to you so you can tell the story about Foodie and ontology and APIs for information systems. Thank you. So we will come back to questions, Emmanuel, concerning Earth observation in ESA. I have noted that, so we will answer that towards the end. Okay, Karel, did you try to share? Yes, you are. Can you also uncamera yourself? You say mute. I don't know how to use what's the right way of describing that, but right. And then we cannot hear you. Is it because you don't speak, or are you on mute? Karel, we cannot hear you. Maybe it's a lag. We see your screen beautifully. And while we are waiting for, then you, maybe
I made mistake. I mute microphone instead of remove camera. Now do you hear me? Yes.
Absolutely. Go ahead.
Okay, so I would like to thank John for introduction, and maybe that I will in some way try to show practically at the beginning how to move from classical model towards RDF on one side, and on other side I will tell some ideas about the hackathon. But I will start a little with the history, and at the beginning I will use some image which is coming from year, I think 2006, 7, 8. Mr. Sorensen done this image, and usually I call this image Poor Farmer. Yes, because you can see that the farmer has obligation to communicate with many systems, many organizations. Usually these systems are not interoperable, and the farmer is obliged to manage a lot of information in different formats. Okay, it is a long time ago. Now we move to the time of cloud. Do you think that situation for farmer became better? I have to say, unfortunately not. I think I a little modified the image, and I can show you that the situation is worse than it was. Yes, because we have a number of systems, but we have also a number of clouds coming from the big providers. every from this big provider is dreaming that he will be able to manage all information. You have satellite providers, chemical, machinery providers, so there is a number of different clouds for farmers, but again, it only increases the number of platform and communication which is necessary for farmer to use. So what is the way? The way is to start thinking how to make all this interoperable and how we can work in some distributed environment, because probably no from this player will be able to take all this information. So I expect that we will stay in distributed environment and that we have to move. So we started to work a lot about this in the time of previous project Foodie. And we start work on the Foodie data model, which included many parts. It included sensors measurement, it included farm information system, fleet management, chemical, and I will at the beginning to speak about the basic core data model. So here you can see the core Foodie data model, which was designed in the Foodie, and it looks very complicated, but I will go very fastly through this model and show that this model has some logic. Yes, so at first you need to recognize the farm, yes, and you need to describe the farm. With the farm are related the fields, yes. So one farm has many fields, and every field has to be described. What is not easy is that usually farmer is not working on one field or having the one crop on one field, but there are the part of the field, so you have to describe the part of the field, and you can have different operation on every part of the field. You can have this precision farming application where you have different zones with different amount of chemicals. You need, of course, describe these chemicals, and you can have samples, soil samples, which are the base also for future fertilization. So this is some idea about the model, and John before spoke about the ontology, semantics, and RDF, and now in data bio we decided to move this model, which was initially done in Postgres and with UML modeling, to move this model into the RDF model. And now I will speak about this experiences with moving this model into RDF. About this we are working now in data bio, and mainly the work is done between LES project and Poznań Supercomputing Center, who is now also running all this database of the model. So we are using D2RQ for translating relational database into virtual graph. We use RDF presentation of the data. We develop farming ontology, which is also linking different type of vocabulary. The data are stored in Virtuoso. And as was already mentioned, as for RDF data, there exists Sparkle language. Now is also available GeoSpark language, which support also querying of geospatial data. And we use more clients. The main which is used in LES is HLayers-NG. So you saw before how it looks in UML. Here you can see the ontology, how is organized the ontology for farming data. What is the advantage is that you are using different vocabularies. You are using namespace. Of course, there is a lot of work because there exists some namespace which could be easily integrated, but for many of the things there are no namespace, and this is something what we have to discuss. And there is also hierarchy of the object. Every object has its own properties, and they are modeled into this model. And for example, here you can see the detailed ontology for the plot with management zones. What is something probably the most linked is precision farming. And here are the overview of main classes. If anybody will be more data interested, both the initial Foodie data model in UML and also this ontology are available on GitHub, are open, and anybody who will be interested to go to the detail, I can send you the link and you can look on this and test it. So it was, as it was mentioned, we use D2RQ to transfer data into RDF database, and here is the link into this for this Spark endpoint. I have to say that in last year we transfer into RDF and Spark endpoint all Czech anonymous LPs without information about farmers, yes, because it is anonymous. We also now start tested to use Virtuoso in trusted treasure, where you can access only some information and you put your password. So we have also some farm already in the system, and we have in this Spark endpoint number of other databases which we can link. If some people are speaking, okay, we have the database of 100,000 points, we have a database of 1 million points. I have to say, in this Spark endpoint, we have now 800 million of triples. So I expect that it is already a really huge database, and we are able to run experiment with this database. And if anybody will be interested to start cooperate with us, you can contact me and I will switch you to Raul, and we will be happy to cooperate on this. Now we are coming to second part, what also was by John mentioned, and it is using satellite images. Here, what you can see are the data from the Czech Republic. We calculate for all Czech Republic yield potential. Yield potential is something what you can calculate it from satellite images, and it is not taking data from 1 year, but you go to the history. You are evaluating every field separately, and on every field you are looking on the dynamism of the changes, and you are looking on the good, medium, and so on. Here you can see this data in better detail. If you will go to this URL, you can test this, and you can really see that all our republic is covered by this data. We are now calculating the same data for the season 2018. We have testing farm, and we are comparing this data with the data from Yield Monitor. This on this portal is the level of resolution which we offer to anybody as free open data. Then we are able, for farmers who are interested or who want to have more detailed data, provided some improving and analysis which are already part of commercial activities. And now I will switch and I will show this as video. We start combine these two data sources, into some application. Both data are running on different servers. Bente, do you see my video screen?
I do see your video screen. Yes.
Okay, so I will start video. I will comment this video, so you can see here application, and we develop interface in our system, and you can query the parcels. The query is sent to Virtuoso, and with GeoJSON you are receiving back to your server the data. You can find farm, you can find parcels. There are no names, there are only numbers. So if you would like to see your farm, you need to know the number of your farm, which is the part of LPIS. So
Karel,
yes?
have you started the video?
Yes, I started. It's not running.
No, then it's not running. It seems like it's on your slide, and I thought, you know, it was ready to be run, but I think then we are not seeing it actually.
Okay, I will probably try to switch.
You need to switch window to screen to share. Yeah.
Okay.
So while you are doing that, I can just say that, well, the replay, for those of you who have registered, who are here, you will get the replay of this webinar sent directly to your inbox. And we will also post it on YouTube later with the presentations so that you can have a look at them. Now
So see you now, the video?
Yes, now it comes. Yes.
Okay, so I am starting. So you have the chance to select with the number the fields. The request is sent with interface to Virtuoso to Poland, and
okay, there it comes. Yeah, it was a little bit slow. Sorry, go ahead.
And you are receiving back the data from Virtuoso, and you can then see the data. You can, for example, ask, because we have also in RDF the erosion zone, so you can ask, give me data about erosion zone, or you can ask, give me data about some water buffer. So there is possible to combine different data and to receive information from different data. And as I mentioned, we have this yield potential. Here is this the basic yield potential, and you can see how what yield potential belongs to which field. So you are able to combine this data from different sources using a combination of RDF. You can also, it is only for the people who are registered. You can also ask about the crops on some farm or some field. So from the database, the information about crop rotation, crop in the application, and you can compare different crop with different yield potential. You can then see the combination of yield potential and erosion zone. So all these are some input data for preparing recommendation for applying of data. Of course, it is also important to have information about water bodies, because also there is restriction on putting some chemicals in some buffers near of the water. So you can see immediately if there are some restriction on your farm. Also, what we add into this application till now is Sentinel Watcher, and you can see for your farm in which days there will be Sentinel-2 data available, new Sentinel data available for your farm. So we are able to integrate this also with weather forecast. So you can see that in a few days they will be possible to use the data from Sentinel, and then is forecast for good weather. So you can thinking about preparing some other recommendation on the base of the data. Now I will switch again to my presentation. So it is plus minus status now, and what we are now starting, or what is idea for hackathon, and what we start to work. As I showed at the beginning, we need to be able in some way integrate the different data and give this to the farm in one point. And there is important to not only support, for example, web application, but also be able support some desktop application. And having a request from some farmer, we decided, okay, we will now start to develop the interface which will allow the same what we done with the web application to provide it using QGIS. So this is now task what we start, and we divided this into more steps. First is to be able to query from QGIS the data in Virtuoso, receive the data back, display, and then query satellite data, and be able to display this satellite data in your QGIS. But what we again recognize, there is number of hub or servers for satellite images, but there is no common interface, and this is what we would like to discuss with you, with other people. There is no common interface how for farm query about this data, and this is I'm sure that we will be not able to solve all this fully on this hackathon, but we want to use also this hackathon as some start for the discussion and exchange of information among different servers, how to exchange the data from the server. So the task is such that you have the data from the farm. Here you have the data on the server, which you saw on my previous video. And farmer would like to receive this type of information, and the question is how we are able to do this. Our idea is to start discuss and define API which could be possible to use for such, and to discuss with the different providers of different hub or different services to discuss common API, because our dream is that if you will run any farm management information system or on desktop or on web base, that you could be able to switch with to different sources of the data, and to query. It could be paid service, but you can query this in a uniform form. This is what is needed for the future, and we would like to start to discuss this. Also, the question is how receive the data back, because it is easy for vector data. So the question is how we can do this with raster data. I think that it was shortly all from my presentation. I tell about the history, about the state of the art, and what we plan to do. And I would like to invite you to start speak with us and work with us on this solution in the future. So hackathon is the first chance to start speak about this.
Thank you so much, Karel. A very exciting project indeed, and an example of how you can use and apply semantics or part of the semantics. Now we have before we go on to the Q&A, like collectively, I would like to select the concrete questions that you have gotten now, Karel, and that is related to the GitHub. I think I saw a question here about GitHub. Yeah, will you give the GitHub link at the end of the webinar? So do you have a GitHub link to share?
We will put this link on the web pages of Plan for All. Yes, where will be this webinar? I will put there the links on the both GitHubs on for Foodie model and also for this Foodie ontology.
Excellent. And there's also a very concrete question related to who is involved. It says, is any of the big players involved in the project? For instance, AGCO or Class, or any startups? Are any of these involved in this?
No. There are no involved this machinery producer in this project, but in this project are involved the biggest IT company in Europe, yes, because the part of the project is Atos, the part of the project is Intrasoft, so they both belong. In the project is IBM. We have the biggest research institute in Europe, VTT, Sintef, Fraunhofer, and we have also some smaller producer of machinery like Zetor, and there is. This is not task from startup, but usually the main partners on the project on the side of the company are could be middle scale SME or larger SME who are involved in this project. So it is not so much about startups, but it is more about the company which are not so big like John Deere or Echo, but which are established on the national markets.
I see. So it's room for several. And then this is Johannes who asked this question. And is there a feedback? So those who are involved, what's the feed? So you mentioned some of the big IT players. So I will just transfer that question to what's the feedback from the big players.
I think that we are discussing this. We are also this is something what I am also discussing with Research Data Alliance, and for your information, I am also chair now of agriculture working group in OGC. So this is also discussed with OGC. Of course, I know that there will be need for some longer discussion and exchange of information, but we are really trying to push these ideas on all levels around worldwide. Yes, we spoke about this with people from New Zealand. It was presented on many worldwide conferences. So I think that many players already heard about this, and of course we are ready to start to modify and do this on the base of the discussion. And also why we are discussing about this on such webinar or hackathon is to attract people to the discussion about such type of harmonization, because without this harmonization we will never be able to run fully smart agriculture. So we are involved not only in the project of Data Bio, we are part of AFAR Cloud project, EUXDAT project. So there is a number of projects, and we are trying to involve people from other producers to start discuss how to do this and how to solve this problem.
Sounds like a very, very interesting project and team to work in. So I don't know if it's you, Emmanuel, who is saying goodbye. I apologize. You are all, a lot of you are friends here. You see that you got the name friend when you register. The system wouldn't allow me to get your register your full name in this application here. So apologies for that, but I think Emmanuel, we answered your question, except you had a comment about ESA. So, and that I think this was related to you, John. John, are you with us?
Yeah, I am. Can you hear me?
Yes, I can hear you. So this is sort of an add-on. This was an add-on question from Emmanuel. You saw it, right? So
yeah. So Emmanuel's correct. There was an ESA program called Heterogeneous Mission Accessibility, which is what HMA means. And so this was linking together information from different missions. I must admit, I don't know where that project ended up, but that's a good one to check out. Looking for ESA's view on some of this technology.
Excellent. So we got that covered. Let me see if you have GitHub. We have answered. I think if you have more questions, guys, go ahead and ask that in the chat. We have spent 1 hour, approximately 1 hour. I will just use this opportunity to say a few words about, while you are writing, about the Inspire Hackathon concept. You were introduced to Plan for All while we were fixing up the presentation for John, but the Inspire Hackathon, as you've heard, this is a webinar as part of the virtual part of the Inspire Hackathon, and we have several Inspire Hackathons. This one here is called the Prague, so we call the hackathons during the year after the place we are organizing them. The main hackathon, Inspire Hackathon, is during the conference, the Inspire Conference. The reason why we are part of or using the Inspire name is that it's all about making the data and the software and the applications interoperable. And we are also about open data sharing and also software or sharing. We also address particularly the Copernicus component, the European Earth Observation Program, and the use and encourage and try to help extend the use of Earth observation data. We are also trying to facilitate and develop the citizen science and citizens observatories component. So all of this is part of the Inspire Hackathon concept. It's not an event, it's a more process, as Karel normally says. This is your words, Karel. Karel, we call him the godfather of the Inspire Hackathon. And we have so-called, and this is funny maybe, since some of us are space people, we call this in between hackathons, the satellite hackathons, so the satellite Inspire hackathons, and we organize several. The concept is so that we have a virtual part, so the teams can form. It's open to everybody, not only in Europe. Whenever you are, wherever you are welcome to be a part of this community and join either one of the teams that you will find on the web page of the hackathon, or you can form your own team or address your own topic. And I have included the link to the hackathon page where you can read more about this in the chat here. You will find a link there directly. So you are welcome to join. It's still time. We have the 10th to today, and the deadline for registry for this hackathon is on the 18th of January. So there are plenty of time to work still. And next week we will have more hackathons. Webinars. Sorry. We will have more webinars on the 16th, and on the 18th, we will have a series of webinars like this. So several of the teams or topics that are being addressed already, you can find a list on the web page. We don't have time to go through all, but you sort of have a menu of different teams. And we will address and highlight topics like we did today with John introducing more generally semantics. We will also have talks about artificial intelligence and also big data and citizen science. So there will be a mix of you learn something new or get an overview if you're in the field, and then you can then join one of the teams and join the hackathon. The finale and the big, face-to-face community building activity will be in lovely Prague. It's a beautiful city. It's great fun. You can also find a report from last year. We had a Prague Inspire Hackathon last year. It's really a great event. So if you can have the time to go to Prague, I highly recommend, but you can still be a part of this even if you cannot travel to Prague. You can join one of the teams virtually. So I think I will end my commercial there for this. Well, we really want to reach out to the communities of to individuals and groups that are interested in the same topics as we are, making data and software interoperable, so that we can develop useful services for society. That's the nice words. Which is true.
Maybe I would like to add one more thing, that we are now running this Prague hackathon, but it is already discussed the next hackathon, and we decided to go outside of Europe. And we are now discussing, and seems that next hackathon will be organized for Africa, together with the conference IST Africa, and people who would like to meet. Again, it will be virtual, but people who would like to meet in situ, so join IST Africa in Nairobi, and you will have a chance to meet there with us.
Yes, and did you notice what Karel said? We are meeting in situ now. So we have satellite hackathons and we meet in situ. This is really the nerdy group here. So I also want to mention the co-organizer. So I mentioned Plan for All as sort of the responsible, the main responsible, but we do have great collaborations with, in this case, in Prague, the Department of Information Technology, FEMKULS Prague, and we have also the Czech Society for IT in Agriculture. We have Data Bio, and you saw Karel's presentation where Data Bio, NextGeos. I'm representing NextGeos. We have also participating in these hackathons before, and we are supporting in different ways like this. John is also part of NextGeos, by the way. We have the SKIN project, Short Food Supply Chain Knowledge and Innovation Network. We have Augstat, another Horizon 2020 project, Polyvisu, another project, Horizon 2020 project, AFAR Cloud, which I don't know what is. That's not a project.
It is project. It is Excel project. It is from other instrument Excel, which is partly financed by Horizon, but partly from national financing.
I see.
It is more industrial oriented.
Right, and then we have CCSS, Wireless Info, LESS Project, and of course University of West Bohemia. So we have, and for each of these hackathons, there are several sponsors, if you like. And so if you are interested, we are happy to discuss another Inspire hackathon, satellite Inspire hackathon with you, with your organization. So we are really all about being open and building the community together. So with that, I don't know. Thank you, Johannes, for being here. John, do you have some comments? I will leave the word for you now to add something, some encouragement of some sort.
That's a great privilege. I didn't think I was going to say something, but thanks to everyone for joining. I hope the hackathon goes well. I think this is a really good time to be investigating this field. I think there's a lot of exciting stuff going on, as we've seen from Karel. So everybody, I wish you luck.
Thank you, John. Thank you so much for an excellent presentation. I thought, I learned a lot. So, Karel, any additional
I would
words
like maybe that you done a lot of advertisement, but probably one more things, yes, because anybody, it is for organization who is ready to help us can become the member of Plan for All. Yes, we are not collecting any fees from our members. We are requiring the work, the people who can help us to move open data, open sources, to move nice application, but also to move commercial applications. So if you will go on our web pages, you can see there also the member session, and you can apply, become member. We are selecting members. It's depend really if people say I am ready to do something for the group.
Yes. Very good points. You are all welcome to join us in many, many ways. Next, don't forget to follow us on Plan for All on Twitter and on Facebook. There you will see more details and be given the possibility to sign up for next week's webinars, 16th and 18th, and the detail will be published in social media either the end of tomorrow during the weekend, or at least by Monday. So thank you so much for your active participation, excellent questions, and we hope to see you again, and we hope to see you in the hackathon. So bye-bye for now.
Bye-bye, see you.
Bye-bye, everybody.